What's up, everyone? It's Alec, back for episode 3 of Code Drop, and it's the moment you guys have been waiting for, interfacing with a database. Yeah, this has been requested, and felt bad for posting the video about the middleware, but it's essential to this video. So I'm not gonna hold anything back. It might be a long one. We'll see what happens, but here I'm gonna dive right in. So first thing, just gonna go ahead and go into my Go path, and I'm actually gonna go into the same exact project folder as last time. Same file, so it's the same program that you guys should have written in the last episode, except this time we're gonna wire up a database. And for my choice of database, I'm actually going to use Mongo. The reason being is because it's a NoSQL database. It uses something called documents, which map really easily to JSON. So you can perform really efficient querying, and overall you just kind of a better experience writing your application. Another thing that you could do is use a key value storage. I've used Redis quite a lot. It's really fast, so you can iterate through a lot of objects, but we're going to use Mongo for simplicity's sake. So what you're going to need is something called the mgo v2 go package right here. And this is what's going to allow you to talk to Mongo on your local machine or in a Docker container, so on and so forth. Without this package, we won't be able to talk to a database unless we write a lot of C code, and we don't want to do that, obviously. We want to write Go because Go is way better. So first things first, I'm going to add something to our config object called a Mongo con string. Actually, yeah, we'll just leave that for now. And this is going to be the connection string that points to the host and port of a Mongo instance. So we'll do Mongo con string, and we're going to do Mongo, or actually, sorry, we're going to do localhost 2717. Add comma. Excellent. So next thing, what we're going to do is we're going to actually write a function that will allow us to get a Mongo instance. So we're going to come down here, say get function get Mongo. Let's get Mongo session. Actually, we're gonna call new Mongo session, and this is gonna take in a con string, and it's going to return an mgo.session. As you can see, we've imported the package using Go imports. So whenever I click save, it'll automatically import that package. I'm gonna do session error equals mgo.dial. I'm gonna pass in the con string, check our error. We're gonna throw a panic because if we fail to connect to the database, then obviously our program is not gonna work. And then we're just gonna return the session from the dial. So now we've done that, we can actually write the middleware that will pass a Mongo connection around to our HTTP handlers. So we're going to call this with Mongo. It's going to take in that first HTTP handler, which in this case would be a router or another middleware. It's going to take a pointer to a Mongo session. And of course, we're going to follow the same paradigm as we did before. We need a response writer, a request, oops, sorry. We do need to name our parameters. So I'm going to go ahead and call the next serve HTTP right here. Basically, at this point, we need to stick the Mongo connection inside that context key value pair. So we're gonna go back up here, declare a new unique key. So we'll do Mongo session key. Click save. We don't need to declare something else because it's just gonna, like I said in the last video, IOTA is just gonna increment 1, so this will be 1 and this will be 2. We'll do new CTX is context.with value. Pass in the request context. Pass in our session key. And we're not going to pass in the direct session, the original session. What we're actually going to do is we're going to spawn off a new connection by copying our original one. So each handler can actually have its own connection and then close it once it's done. So we manage memory quite well. Instead of closing the original one, then the rest won't be able to talk to Mongo. So we're going to do session copy equals sesh.copy. We're going to defer sesh copy.close. So once this function, this function, the literal, finishes, after this is called, the copied connection will shut down, so we manage memory. And we're going to pass in that copied session into the new context, and we're going to assign it to the request. All right, so we have our with Mongo middleware. The next step is to actually get a Mongo connection. So in this case, we're going to do mgo sesh equals new Mongo session. I'm going to do c.mongoConstring. And then we're going to do, remember, we created middleware. So we're just going to wrap this with Mongo session. Sorry. So basically, we're just layering middleware, and it's going to be executed from outside in, basically. Being this is the first, this is the second, so on and so forth. Now, the reason this works is because all our middleware implement the HTTP handler interface, so we can just layer them on and stick the router at the very middle. Now, this is the important part. We've set up our Mongo connection. Our functions are now able to use it, but now we have to actually store something. So I'm going to create a car struct. We'll say we're building a car management system. Actually, no, we'll build a user management system. User struct. And users have names, JSON and name. Now, notice how I'm adding another tag. This is because we want to create a one-to-one mapping in our Mongo document, and the language that the object notation that Mongo uses is called BSON. So instead of JSON object notation, it's binary object notation. It's similar to a Google protobuf, but not entirely. Let's say they have an email and an age. All right, so we've created a user object. Now what we're gonna do is we're gonna actually, oh, I forgot a step, and this is pretty important. Remember how we created this function getConf that actually pulls something out of a middleware? We need to do that with our Mongo connection. So we can say get Mongo a context as a parameter, and it will return a pointer to a Mongo session. Sesh, okay, it's the same exact syntax, just different values. Typecast, check the error. Mongo session not in context. Return session. Okay, so it's basically the same thing. Now we can come down here. We can pull the connection out, saying get sesh get Mongo r dot context. Now we need to reference a database and a collection inside of Mongo, and the way we do that, do sesh db, say users. Oh, actually no, we'll call this, we need a name. We'll just do user. And the collection, users. So we've pulled our collection out of a Mongo database. Now we can start using it. So what we will do is we will create an object in this handler. We'll stick it in the database, and then we'll pull it out and send it to the browser. That's a really inefficient way to do things, but for demonstration purposes, of course. Usually you'd create a handler for each CRUD operation, create, read, update, and delete, so you have a full RESTful API. We won't do that. We'll do that later. So what we're going to do, call.insert. Actually, does that return an error? It does. So call.insert. We won't put in anything for now. Error return. So it does not execute anything after. We're going to create a user. Let's see, user. I'll do myself. My age, I'm 19. Oop, that needs to be an integer. And we will insert the user. Sorry, you. Okay, and then we insert the user. So what this has done is it created an object in memory, inserted it into the database, and hopefully all was successful. So now what we can do is we can do a query, which will basically look for an object in the Mongo collection and pull it back. We can send it out to the browser. So we're going to call.find. And our query is going to be a BSON object of type. We will need this package as well, but it comes inside of the Mongo. we need a bson.m map, essentially, and going to query for the name for Alec Holmes. And we'll do a call.find and we do, there's a method on this. Is it one? Yeah, because we're only going to get one object back, right? So we'll do query type user. Unmarshal that into UR. Let's see, does that return an error? It does. So we can check our error. Just copy that. And what we're gonna do is then, what we're then gonna do is send back what Mongo gave us to the browser. And we'll do that through a function called JSON.marshal indent UQ. We don't want a prefix 1, 2, 3, 4. Check the error. W.write the bytes. So we've basically wired up our database. Pretty simple. Only way to test it now is to run it. And in this case, go run main.go localhost 8080. This should fail because I did not start a Mongo instance on my machine. Yep, and we got an error. No reachable servers. Excellent. So I'm going to come over into another shell, start up a Mongo instance. And now I'm going to run main.go. I might have gotten the IP wrong. Okay, so we are talking to Mongo. We can see that insert users documents. We did insert something into the database, but it doesn't look like we pulled it out properly, which I believe is because this query is incorrect. Ah, yes, we needed to provide a pointer. That's a stupid mistake. So without a pointer, this doesn't know what memory address to stick the object in. So we inserted the object into the database. We went and pulled it out of the database and we wrote it to the browser. So now what we're doing is actually pulling data from a database and sending it to the browser in JSON form. And you can see the rest of our text. And we can stop our application, can run it again, and the information is persistent. We can build a binary even if we wanted to. And it still works just as we planned. We can see all those GET requests that I just hit with the refresh button. Awesome. So if you guys want a video on how to set up your local machine for Mongo, because it's kind of tricky, I can do that. Other than that, I mean, this is pretty basic. It's rather self-explanatory. You just read the documentation. I'm just here to simplify things. If you guys have any questions, let me know. I hope that you found this tutorial helpful. Thanks for watching, and stay awesome.